This is the advanced session for the Hummingbird control, and what we're going to be talking about is using the getting started using the pieces of your Hummingbird kits and all your little components that you have there. But I'm going to get you started with Snap and the Snap platform. So if we take a look at the Snap platform here, you'll see that we have some things that if you were with us in the first session, you will kind of know already about this, but we're just doing a quick refresher. And I'll go into the different pieces. I usually go over this with my students as well, so that we're all on the same page about the vocabulary and what means what when we get into it. I actually have a worksheet somewhere that I've used with my students just to get them to write down the different parts of the block editor so that they can have that in their brain and have a good visual of it. So we do have the stage here, and on the stage, that's where your code is going to run. You have some tools that are underneath here that will give you a new sprite or allow you to paint a new sprite or create a new sprite, or you can even use your camera to take a picture to create a new sprite. And then you have your sprite icons, and as you build sprites, they'll live here in the sprite corral. You will always have a stage icon, and that's what this is right here. And this right here will allow you can code in the stage or keep some things in the stage that you don't want in the rest of your code, or you don't want to get lost in the rest of your code. You can just kind of leave it in the stage if it's something that doesn't really relate completely to one sprite or another. Then you have your blocks palette, and you have your palette buttons that will take you to the different blocks. You have your scripts where you will code. This is your scripting window, and it has 3 tabs. You have your scripts, you have your costumes or your backgrounds, and then you have your sounds. I'm sorry about the cat meow that's in the sounds. If you let your students know about sounds, sometimes it gets a little crazy, but we will be using sounds with the Hummingbird, but I'm sorry. I'm just going to put that out. Then we have our Snap logo and our menu, and this actually will take us to our help. We have our file menu, which is where our save and save as, our open, import, and all that lives. And this is our cloud menu where we go in to sign up. Our settings will allow us to change our languages, the size of our blocks, all kinds of wonderful things. And also, if your code comes up and says it needs JavaScript, that's the button you're going to push to go and make sure that JavaScript is connected. JavaScript extension is connected. We have our visual stepping, which will highlight each code as you go through if you have that selected. And so this is the basic Snap environment. Now, we have our ExCITE BJC curriculum. And if you have the links open, you can click on it. And this will take us to the bjc.techlit.org. This is taking you directly into the curriculum. If I were to just pull up the bjc.techlit.org, it would take us to this site, which is another good landing page. So you've got the BJC curriculum, and this is the TechLit curriculum. So this is the curriculum that will have the Hummingbird activities to it. We have the teacher guide, anything about teacher PD that you may want to know, run Snap now, and BJC is in Spanish. The Hummingbird pieces, I do not believe are translated over to Spanish yet. It may come. That could be worked on, but we do have the curriculum, the rest of the curriculum in Spanish for you. Okay, so you can click on the curriculum, and this is how you get to what we were looking at before. All right. And so we have a certain lab format. If you're in the curriculum, you can take a look and it will open up. This is our introduction to programming for Unit 1. And I'm going to maybe go here to making programs talk. So you have different things like this. There's always a pink box at the top that will give you what you're going to do. So the objectives of the particular page. And if you're starting at the beginning of a lab, it'll give you the objective of what we're going to do in the lab. All right, so I'm going to go back to the slides here. You'll note that there's like the green boxes, and the green boxes are definitely going to be the things for the students to do. And I was just looking here at the pink preview. So I'll just stay in the slides for a second. But if you have your curriculum open, you can kind of take a look at it as well. So we've got our overviews. We've got our 4 to-dos. Then we have our yellow blocks, and those are going to be kind of like hints and side notes and things like that. There's some really great information in the yellow blocks that are in the curriculum. I highly recommend that you take a look at them as you're reading through. Your students will learn that they don't have to look at it. And then they get stuck. And then you can take them to the yellow block and have them look at what's in the yellow block, and they'll be able to read it and figure out a little bit more. We have the orange. These are important for all students to read. So we've got some vocabulary in here or some different things in here. And so the orange blocks are important. We have our blue, and that's going to be for if there's time. So if you have students that are moving along a little faster than others, there are some good challenges for them to move into the next thing. They are fun. So what will happen is some of your students who are moving slower will want to do this, the if there is times. And depending on where you are in your curriculum, you might be able to let them do that. But it will slow things down. They don't have to do the blue. They don't have to do the purple. Those 2 are things that are for students that are moving faster through the curriculum, or if it's something that's very interesting to you and you want to cover that particular topic. We have our gray, and our gray is going to be our vocabulary and any kind of AP exam information that will be on the AP exam. And so those are very good if you are, you have students that are definitely taking the AP exam. It's very good for them to read and understand. These are put into, the vocabulary is listed as you would need to know it for the AP exam, and how it's connected also to the curriculum. Okay, we now also have our teacher guide. And is it still BJC teacher, Tony? Okay. So for signing in, you're going to use, I don't know if you've done this yet. It's BJC teacher. And then it would be capital debug. No, it's not debug, is it? What is it? You're on mute. I don't want to take it out of here. Maybe.
Yes, it is debug.
Okay. So for this one, it is capital D, lowercase e, capital B, capital U, lowercase g, lowercase g.
Is the link in the presentation? Mine's coming up with an error.
Hang on just a second. Let me go back to the presentation. So this is coming up with an error for you?
Yeah, okay, let me make sure I'm clicking on the right link. So I'm in the presentation, long presentation. And it says BJC dot teachtechlit.org. Is that the link I'm supposed to be clicking on?
Yeah, the bjc.techlit.org should take you to this page.
No, it's saying page not found.
Okay.
Yeah, it is a redirect. So it takes a
Here.
couple of seconds. But if all else fails, if you just type in, I'll put the
I put the link
address
in the
into.
chat. I put the link
Okay.
in the chat.
Okay, thank you.
Thanks.
Yeah, that should work. But when you click on that, for some reason, it actually does a redirect. I'm not actually sure why, but it does get there eventually.
Oh yeah,
But
redirects. My district computer does not like redirects.
If
That
you
would
click
be
on
what.
teacher sign up, Heather, it should take you there. In the middle of that page, teacher sign up, it'll take you there.
So once you get here, you can click on the teacher guide. And this will allow you to get into the teacher guide. So to get into the teacher guide, you'll need the password, which is debug. And it might be on the slides, but I will also type that in the chat.
yeah, please. That will be perfect.
DUGG. Okay. So that is
Username?
okay. All right. So username. I'm sorry. Thank you. Username would be BJC teacher. My apologies.
Is that with a capital or just all?
No,
No,
all lowercase.
just
All lowercase.
all lowercase.
Thank you.
You are welcome. I have mine saved, so I don't often need to remember what it is. Okay, so we have our introduction to the teacher guide. This is how you get in. There's some great stuff here. Okay, let me go into the teacher guide really quick, and I want to show you a little bit. So when I go into the teacher guide and I click it, it comes here to this first page. We have some teacher resources. I highly recommend just clicking through all of the things over here on this side, on the right side. We all have those students that are coming in late to our class because they got transferred into our class after the first 5 days or 7 days that they promise you your class will be running, but you need to get going because this is an AP course and you've got to get through the information. So we have a SNAP crash course for students that are coming in late, or if you want to kind of refresh right before school starts, go ahead and hop in here and take a look at what's going on. Any development updates will be here. And then you have a SNAP cheat sheet. Now, this is also on the regular curriculum page. Sometimes I will take all of the blocks for SNAP out and have the students go and create these blocks to put in the sheet. Just again, depends on how much time you have. This past year, I started with my students on January 29th, and I had to have them ready and the AP create task completed the last week in April. So it was a really tight turn for me. So I couldn't do a lot of activities that would help them have a better, deeper understanding. But that's one activity that you can do. So back to this. So you have some good stuff here. The teacher resources are important to take a look at. All kinds of links and information. If you don't know where to get something and you don't want to email anybody yet, come here to the teacher resources. It should be able to help you out. All right. So we'll go ahead and we've got the introduction to the teacher guide. It talks about it's the goals of the curriculum and how it aligns with the BJC, how it aligns with the AP framework and things like that, what the pacing looks like, what the student labs are. Different ideas of assignments if you get stuck on what should I do with my students. There's different ideas. Also, it talks about some of the things that we have here. We have computer scientists at work, and they're all throughout the curriculum, which will show your students. That it'll talk about computer scientists that maybe they can, where your students can maybe see themselves. So a diverse group of computer scientists there, and how to use that in different things. And it talks about the design elements. So this is all also in your teacher guide, and it's just in the introduction to the teacher guide. Where you're going to be mostly using your stuff from is your Unit 1 teacher guide, Unit 2 teacher guide. Those are where you're going to spend a lot of time. It talks about what the purpose of this unit is, any social implications, so what the focus is going to be for that. And then it goes into the big ideas. So if you need to show how the AP course is relating to the BJC Tech-Lit curriculum, so the ExCITE curriculum relates to the AP exam, you can come here. We have videos on a lot of different things. So if there's something that you don't know, you can click on the video page and you can run those for your students in your class. Those are a lot of Dan Garcia over in Berkeley that he uses for his class. Then you have your teacher guide for each individual lab. Notice we have minutes here for how long it should take. And so we have 40 to 80 minutes. Well, yeah, that's a wide range, but we have a wide range of students that we have coming in. Okay. So we do this in minutes because classrooms are different. We have some classrooms that are going to be 45 minutes and some that may be 90 minutes, or, however that works for you. So we chose minutes to give you that for your pacing guides. And then you have your classroom, what is covered in your AP classroom. It's very important that you go into AP classroom early and work with your students in AP classroom early. And this one, for Unit 1, Lab 2, strings are what is related to Unit 1, Lab 2. Then we have our assessments and solutions, where you can click on this and you can get more. Well, I have to sign in. I do. So we'll have to make sure that you have access to these, the assessments and solutions. I don't know if they've changed anything, but you can come here, you can click, and you can, when you click on these boxes, this will open up the coding solutions for you. And as you go down, you'll find that there are some multiple choice items along with those solution sets for the multiple choice. And you can just come in and click on these, so you don't have to reinvent anything. They're here and they're available for you. All right, let's get out of this and all my emails. All right, so does anybody have any questions? Oh, hang on, one more thing I want to do. I want to do Click Alonzo game. Each unit for the teacher guide, you can go into the Click Alonzo game, and you have the pacing for those each individual labs that they'll be working on, and what you might need to or want to prepare before the students come into class. All right, has some of the information. So if you get stuck, come here, take a look if there's the things you need are in here. If not, reach out to one of us. Okay, so I'm going to go back here, and we reviewed the teacher guide, and now we're going to do a warm up, and we're going to do a follow the leader activity. Okay, so do I have everything in the code? Hang on a second. Well, we'll talk about this first. Let's I'll open up where the follow the leader activity is. It is in Unit 1, and we are going to get our mouse to kind of follow along, or actually have this one sprite following another sprite, etc. So the follow the leader is going to allow your students to kind of, not your students, your sprites, to move around the screen based on where one sprite is versus the other. Okay, So this particular one, we're going to have a sprite follow your mouse, and then the second sprite is going to chase the first sprite. And then they're going to meet and they're going to have a little conversation. All right. So, Tony, everything is in here, so I don't need to go into the curriculum. You're on mute.
Yes, on slide 14 is where in fact, the next slide.
Okay.
The teachers will need to open, have the
Okay.
BJC curriculum open at Unit 1, Lab 5, page 1.
Okay. So we're looking at the follow the leader page 1 here, and we've got logging into Snap. So let's go ahead and get logged into Snap and run this script and see what we're going to be doing with it. Actually, this is good. You're in the curriculum. If you are in the curriculum or even in the teacher guide, you can access this. So if you get into Unit 1 and you scroll down, we're going to be doing Unit 1, Lab 5, follow the leader. The very first one is following the mouse, and you can see these guys. There's wonderful little clips. So the students can see what the program's going to be doing, or the user can see what the program, or the coder is can see what the program's doing. It's not just for students, it's for us too. So here's where we're going to be going. I'm going to put this in the link copy, and I'll drop this link in the chat here. So this will take you directly where you need to go. And you're going to start a new project. So you're going to open Snap, and Snap is linked in here. You can click on once you get into the page, you can click on Snap. And this is where I'm going to adjust my windows. Not on that screen, I'm on the wrong screen. Here we go. That is not what I wanted to do. My goodness, I put it over here. There we go. Thank you. And then I'm going to open up my Snap and try this little link. Oh, that's nifty. You guys keep doing nifty things, and I find new things happening. Okay. I'm going to decrease the size of this just a little so I can make this side smaller. Okay. So if you need help putting your screen side by side on a Windows machine, you can just do you can do the windows and you can do your arrow keys, and that'll allow you to have your screens kind of side by side as you like them. On a Mac, you're going to have to adjust them. But it's good to have everything up on the screen at the same time if you can. If you have a small screen, I'm going to leave mine up, and we're going to kind of walk through what we're going to do, unless we want to go into breakout rooms. But I think if we just walk through, because we just have we have 30 minutes to finish this up before our meeting. Am I correct? Okay, cool. So let's go ahead and make sure we have our Snap open. And then we're going to, if you had something else up, just make sure you come up here and you're on new. If you have a new Snap open, it's clean. It doesn't have anything in it. All right. And we're going to do a save as. And we'll want to save this project as, it has it right here. I've got my screen so narrow that it's hard to read, but we're going to do, first of all, we've got to log in. If you haven't logged in, click your login button and go ahead and get logged in. And I changed my password, so it's ridiculously long. That's me. Okay. Google kept bugging me about my password being compromised. So I'm just like, there's nothing attached to it. They can have it, but it's okay. I'm a cybersecurity person too, so I have to practice what I preach here. So now we have our cloud. If your cloud does not have, if it's not opaque, then you're not logged in. So you'll need to make sure you're logged in. You'd also click on the cloud. It says, if it says log out with your username, then you're good. We are going to do a save as, and we're going to do, this one is Unit 1, Lab 5, Sprite. Yes. And I'm putting EX24 just so I know which one this is because I have too many. So now I have that, and it's I have a title in this Snap platform here. All right, so then you kind of go down and let's go ahead and get started. What do we think this script is going to do? Can somebody tell me?
One sprite is going to follow the other. I guess we'll have two turtles maneuvering after the
Okay.
other.
Okay. So we're gonna we've got something's going to be following the other. The sprite is going to be following something definitely. So let's take a look. Let's go ahead and code this. We've got our control button. You're not 100% right, but you are so close that this is really good. All right. So we're going to go to our control button, and that's going to get us our orange items here, like the when green flag is clicked and the forever. So let's go grab those, because I want to look and see what this thing does. Right now, I mean, we have the platform, and these are like 3 lines of code, so we should be able to test this. Always want to be testing. So we have a hypothesis that the sprites are going to follow each other. All right, now we have the motion is blue, and it's listed as motion. It's on the top left-hand side of the palette tabs here. So click on that, and then you want to find the go to. Now this one says go to mouse pointer, but if you scroll down here and you find this is go to random position. We probably used this block when we were creating our Click Alonzo game. But if you click the drop down arrow here, it's going to give us some other options. So I want to go to mouse pointer. Okay, and then if I click my green flag, let's open this up. If I click my green flag, oh. Well, it's following something. What is it following? The
mouse pointer.
Yeah, it's following the mouse pointer, right? So it's following the mouse pointer. So wherever my mouse is, it follows. I could do that all day, so let me stop. All right, so it's following my mouse pointer. Now, notice if I bring my mouse off the screen, where the sprite goes off the screen too, right? The sprite is really following your mouse pointer wherever it is. So we'll have to stop it. And then, of course, our sprite is off the screen because we had to stop it. And if we don't see the sprite, we can right-click on it, and we can click show, and it'll come back on the screen for us. While the code is not running, it does not follow my mouse. Okay. Oh, so we already did. We already did 3 and 4. We're working ahead. Who knew? We have a computer science test at work here. just kind of sprinkled in through the curriculum. Okay, now we've got, we're going to create a second sprite by clicking on add a new turtle. Okay, so go find your add a new turtle and click on that. What happened to the code that was on my screen? Why did my code go away?
Now you're editing the second sprite.
Because I'm editing the second sprite. Very good. So we have the first sprite still has my code, and the second sprite doesn't have any code because I haven't put anything in it. All right. So the new sprite automatically named sprite 2. It appears on the stage, has no scripts, and that's in the yellow block. So let's see what we're going to want to do with this. So to make your sprites meaningful, it wants us to change the name of sprite to leader and sprite 2 to follower. So to change the names, we can come here and you'll see where it says sprite 2. And sprite 2, they said follower, F-O-L-L-O-W-E-R. Sorry, I spell out loud sometimes. All right, so that one's follower. And then I wonder, I'm gonna check. Can I rename this thing here? No, I cannot. Sometimes when you right click, you can do some different things with your buttons. So always check your right click out. So this, I'm gonna rename this sprite to leader. Okay. Why would we want to name our sprites instead of sprite 1, sprite 2, sprite 3?
So you
So
know
that
what
you
they're going to
remember
do.
the purpose.
Right. I think I got both of you. One was, so you know what they're
Yeah,
going to
so
do.
that so that you know what it's actually going to do, what the actual function is going to do.
Yeah, and I think Tracy said something about, so you know the purpose, right? That's right. Is that, I think that's what I got. So yes, absolutely. So naming things with purpose is important. And when you get into naming your variables, you're going to want to name them with purpose as well. You want to make sure that you know what that thing is. So using random things, you can use sprite 1, sprite 2 all day long if you want. That's up to you. But it's much easier when you come back in to work with the code to remember where things are. Okay, so we changed the name of the sprite. Ooh. Now it says we want to make sure our follower sprite is selected, and we're going to write a script for followers so that once the green flag is clicked, it will point upward. It will point toward the leader forever. Okay, and it shows us what block we need to get. So I'm not on the right sprite, so I'm going to go to my follower sprite. And then it says we should go and get our point towards. And that's in the blue as well, which is our motion. So motion, anytime your sprite is going to be moving, that's your motion stuff. And it wants us to do point towards. If you want to, there is a little button here that's your magnifying glass for your search, and I can type in point, and this gives me anything that has the word point in it. And here's the one I'm looking for. Okay. Point towards mouse pointer. Now it wants us to do this, that once the green flag is clicked, it's going to point toward the leader forever. Okay, so I know that I got to get my green flag. And I know I'm going to be using a forever block because it said forever. Okay, so these are the blocks I'm going to use. And we want to do this all the time. But this right here is just mouse pointer. So am I on the right one? Let's see. Follows the leader. Well, let's see what other things I can do. Ha, look at that. Leader is on here. So it adds the other sprites here to the bottom. Before I had the names of the sprite, it would have just had sprite 1. Okay, but now it has leader. So it's going to point towards the leader. So now let's run our code and check to see if it works. Okay, let's check to see if this works. All right, green flag. Okay. Uh-oh. It's pointing, but it's not following. Okay. Let's see. Is that what we're supposed to do? Let's check it out. Let me stop my code. Show my leader. Okay. So the leader always follows your mouse when you move your mouse, and the follower stays in one place but always points towards the leader. Okay, that worked. Let's go ahead and save our work. We click on our tab here and just click save. We've already named it. We don't need to rename it. And it wants us to go to the next page. Again, on each page, it's going to give you what's going to happen, what the goal is for this particular page. All right, so now we want to change the follower's code to point towards the leader only until it is touching the leader. And then we're going to, well, do some more stuff. So let's do that. Here's a picture of the code being built. Okay, so we're looking for touching the leader. We're going to point towards the leader until we're touching the leader. So we have nice little videos of what is expected and everything. So let's go ahead and do that. Repeat until, or repeat, not repeat until. So repeat, and we want to repeat it. We do want to repeat it until something happens, right? So let's go get our something. This is our sensing. So if it's touching, so that's a sensing thing. That's a sensory thing. So we're looking for this. Hop, there it is. I missed it. It was at the top. So when it's touching the mouse pointer, oh no, we want to go to leader. Oh, am I in the wrong thing? Select the follower. I am in the wrong thing. Look at me. I'm in the wrong thing. I don't want to throw this code. I don't want to have to go redo all this. So I'm going to take this code, and here's the way you can duplicate from one sprite to another. If you take your code and drag it until the other sprite is kind of a little highlighted and let that go, it'll be duplicated on the other sprite. And I threw that away because I don't need it. Okay, good. Here we go. This is what I needed. Okay, so we are swapping this out. And I think I remember. Okay, so I think I remember from the video here, I got a repeat. Oh, wanted me to do a repeat until. This will work though. It's the same thing. No, it's not. Let's go ahead and fix that. Here's the thing that you can do to fix that. Remember when I said right click is your friend? If you right click, you can click relabel. And I want to change it to repeat until. And I can click on that box instead of having to go and find repeat until here. Okay. I'm not sure if this would have worked if I had just used the repeat, but it might have thrown an error. So I could have tested it. I didn't,
Question for you.
yeah.
When I run my scripts, that follower is going super, super fast. Is there a way to slow everything down a bit?
Sure. You can, so follower is going fast. So if you want
Yes.
to, you can click your visible stepping. And when this is on, oh, well, yeah, that goes really fast, right? But I can slow this down. And it's when your visible stepping is on that it'll go slower. Because you can bring this, you can also put in a wait if you need to, if it's going too quickly.
Okay, thank you.
Mm-hmm. So we're going to put our point towards leader. Is it point towards leader? Yes, we're going to drop that in here. Okay, so we got our stuff. Oh, I didn't change this one when it's touching the mouse pointer. No, I want to go to leader. All right, so now we have our code. Everybody have this? I'm going to throw that away. Okay, what happens now? Uh-oh, it stopped once I touched it, right? So let's stop our code and look at that again. So it points towards me every time, but until once I touch it, it stops moving. Okay.
Marnie, can I ask a question?
Mm-hmm.
It's a little confusing when you're looking at both sprites on the screen to remember which one is the leader and which is the follower.
Uh-huh.
Can we change the costume of one of these so that it's clear which one is
Sure.
the leader and which is the follower?
Sure. So let's go ahead and change a costume. We're going to change our follower. And we can go grab a costume. So if you are on your sprite and you go to your costumes tab, okay, and then you come to your file here, this is where your costume library will live. So these are the ones that are built in. Students can use, or you can use different ones. Let's see. Am I going to do Alonzo? I'm just going to pick a couple. Ooh, I've got a bat. I'm going to do a bat. And, oh my goodness, my bat's upside down. Okay. And then I'm going to go to the leader, and so let's do a leader, and I can do Alonzo for the leader or something like that. Same thing. I'm down to costumes, opening up my costumes. I'll have Alonzo. Got too many. Just need one. Okay. So now you can see Alonzo is the one that follows my my mouse, and you can see that our bat is upside down. Oh my goodness. Can we stop following my mouse? There we go. And our bat is upside down. So you might want to change our bat to be rotated. If we want to edit our bat, we can come here. Pretty sure we can rotate it, but maybe not. We'll go to looks and see if I can fix this. I can fix it later.
If you right click on it, it can give you the rotate option.
There you go. See, look at that.
So I've changed the costumes and now nothing is appearing.
Nothing.
Like they've gone away. Everything's gone away. Oh, nope. My pink arrow. I changed my follower to a pink arrow, but my leader is now gone.
Is your code running? If your code is running, it's because your mouse is off the screen. So if you bring your mouse over to the screen, does it show up?
Okay, they're both now physically there. It is running, but they're not turning anymore like they were.
Right. Okay, so let's go find out why that happened, right?
They were touching, but now the one is just sitting there.
Right. So if we stop our code and we run the code again, okay, so as I move around and I'm not touching, the other sprite will follow me. But once I touch the other sprite, it stops moving. Let's go look at our follower code and see why that happened.
Okay, it is working now.
Okay. So when it's going to repeat what it's doing. So when the green flag is clicked, it's going to do this until the leader touches it. Okay.
Just wanted to give you.
I have the same problem. Why are the code is no longer showing on the script? Once
you have to make sure you're moved back to your scripts tab. If you're in costumes, you'll have to go back to the scripts tab.
Thank you.
These are all questions. Yes, Stacy, go ahead.
Can you go back over how to get to the costume library?
Sure can. I'm going to make this bigger too. Okay. All right. So to get back over to the costume library, you're going to select your little sprite, whichever sprite you want. Up here, you have 3 tabs. I've got scripts. That's where I'm going to see my scripting area. I've got costumes. And then I have sounds. Okay. So I have my bat. To get another bat or to get something else, if I wanted a different costume, I come over to the file tab or the little tab here, the document tab. And it opens up and I scroll down to costumes. And once I do that, it will open up. Now I will tell you that your Chromebooks are going to be slow to open these costumes, which is why we tend to have starter code that has costumes already in it. And then you can scroll through here and grab some of the costumes that you may want.
Thank you.
All right. It's kind of the same thing for the stage. I'm going to click on the stage. Let me go back to scripts. I'm going to click on this. Yes.
Oh, we're at 9:56. So
okay.
we're
We'll finish this up then real quick.
Got it. Good.
Okay. Let me 9:56. So that gives us 4 minutes for a break. Is that what you're saying? You're on mute.
If you wanted to continue to a natural break point, we can push the break back a little.
Okay. Okay. So let's go ahead and get this, see where we've gone. We've now followed the leader. Now we know that it can, it's touching, and we can move some steps. It does want us to add some move steps to our follower. Okay, so the follower doesn't just stay in one place. So we can add some motion to this, and we're going to move, type a small value in this slot. I will tell you 10 is small, or 15, whatever you like. Add that. And when you click your green flag, wow, that touched really fast, didn't it? When you click your green flag, it doesn't give all my screen. That's okay. When you click your green flag after that, whoa, stop. Green flag.
You move one step, it's
1 step is too much.
1 step is okay.
1 step is okay. So
Yeah.
moving a very small amount of steps, 15 is too much. And that way, it'll kind of glide towards you. So notice how it moves towards you and follows you. 1 step is good. Thank you, Michael. All right. And this will go and you can do more. So once they touch, they can start talking to each other and things like that. But that is where we kind of wanted to get with being able to follow the sprite, one sprite following another sprite, and also a sprite following the mouse. Does anybody have any questions? Okay, I'm going to stop my share. And Tony, take it away. Oh, wait, I have Stacy had a question. Go ahead.
Oh, I'm sorry. I just forgot to lower my hand.
Okay, no problem.
Thank you. Thank you, everyone. Hi there, Megan. We're running just a little late, so if you don't mind, we're going to take a 5-minute break and come back at 5 minutes past 10. So, folks, if you'd like to stretch, etc., and we'll see you in 5 minutes. I'm going to pause the recording so that we don't have empty space in the recording when it's shown a little later. But please feel free to take a 5-minute break.
All right, everybody be able to see that? Thumbs up. Great.
Yes.
Wonderful. Thank you. Okay, so I'm Megan Garvin. I'm the Associate Director, excuse me, for Research and Evaluation at the Maryland Center for Computing Education. And we work across the entire state of Maryland and focusing in on having all of our school systems go through the script process. And we also have customized it so that we can take a look at the school level as well. So a little bit about this in case you've never heard of it. The script process, script stands for Strategic CS for All Resource and Implementation Planning Tool. And this began way back in 2010 in New York City, actually, when they started to say, okay, what is computer science? Why is it not in our schools? And why are our students not ready for the 21st century? So they began to implement that. And over this timeline, this is just a basic overview. They now have gone to the national level and brought it to other states and territories and actually globally as well. And really having school systems take a look at it and start thinking about where are we in the process? What can we do for our students and teachers? And then where do we go from there? So why is it this process? Well, we know one size does not fit all. Each system, each school is very different. This gives the framework for you to be able to assess where you are, where you want to go, and what you want to do. Setting the priorities, setting the goals, and we'll talk about that in a minute, that actually fit the needs of where you are with your school and your school system, and then integrating into the existing infrastructure process so that you can move yourself along. So Tony has another detailed document that you'll also be able to look through step by step, but this is just the basic overview. We'll help you assemble a script team. We know that we want teachers' voices involved. We also want to have leadership and others at your school system. Could be that maybe you're having issues with IT and connectivity. So we want to have someone that would be representative of that. We want to broaden our participation in computing, particularly in this study for Hispanic and Black students. But for students who are not necessarily taking computer science courses at your school, we want to be able to open the doors to them. So those schedulers or guidance counselors or professional school counselors, whoever that would be, identified within your school. Then as we bring the team together, and we'll help you with that assembling of that team and identifying those people, you'll work through the script process, which is a rubric that goes through many different components and subcomponents to take a look at and assess where you are. And then once your team does that, we begin to look into what's called SMARTY goals. We'll get to that in just a minute. And then you'll be able to see progress as you move through 3 months, 6 months, a year, 2 years out. So we know that we've been successful when we have teachers like yourself who are early adopters and go through professional learning and begin to integrate things into their classroom, but that only will service just a small amount of students. So then we have to think about larger landscaping, planning, ongoing collaboration, how to continue to bring computer science to our students, knowing and understanding that many of our teachers that are in-service teachers did not have computer science themselves. They don't have mental models around what this is, how it can be integrated. And with the ExCITE program, it's a really great opportunity to bring robotics into the high school classroom and really have our T&E teachers step up and begin to learn coding like you are yourselves. So the full rubric goes through materials and curriculum, leadership, partners, infrastructure, community, teacher capacity, and development. So in this case, you have already, with your principal, identified the curriculum that you're going to use. You're in the professional learning now, and through the summer, we'll be learning more about the course, and we'll be teaching this particular course. But there's so many other areas and structures around the school that also need to be in place in order to make sure that we're able to broaden participation for our students. So this is an example of the leadership subcomponents. Each of these subcomponents has a separate rubric, which your team will work through. Think about where you are in that process of the rubric, and then think about how you can move from one level to the next, from novice all the way up to well-developed. So what are SMARTY goals? You probably have already heard about SMART goals. S stands for specific, measurable, achievable, results-focused, time-bound. The IE is what's been added, inclusive, bringing traditionally excluded individuals into the process, having them have the opportunity access to complete a course like this. And then equitable, making sure that it's fair, making sure that there are other places. And so, for example, with your scheduler, making sure that if many of your students have to take any other particular required, maybe it's mathematics or English language arts, that it's not always in juxtaposed against that, where they wouldn't have the opportunity to opt to take this type of course, and trying to think through that more holistically throughout the school. That's just one example. So as we go through, you'll take a look at where you are on those different subcomponents. You'll select some of those areas where you feel like you have areas to grow, and then you'll be able to put in your SMARTY goals and figure out where you want to go in the next 3 months, the next 6 months, up to a year. So one of the things I've done in Maryland is we have our dashboards, and you'll have access to this so you can take a look at it and link down here into the dashboards. But you'll be able to see we have tracked this intersectionality at the state level, at our district level, and all the way down into the high school of what's been offered year over year and what is their progress. We are one of the first states to have 100% access to computer science in all of our public high schools, which we just achieved last year. But it took us a good 5 years and a lot of intensive work across our entire state to be able to do so. So I'm going to open it up for questions and stop sharing. Anybody have any questions about the script process and what we're going to try to help you accomplish? And again, you're not on your own. This isn't something you have to do all by yourself. We're here to help you. We're here to help your principals and whatever else we can do to help you recruit more students into your classroom, particularly those that are Hispanic and Black.
Would it be possible for you to share your PowerPoint with us?
Yes. Yes, Tony will give you that PowerPoint as well as another
Yeah.
document that kind of walks you through a little more step by step of how we're going to do this in the fall, and what we're going to try to accomplish with your help. But we, like I said, we want our teachers' voices at the table. We have had very successful meetings with teachers. When we do district level, it's across the articulation, depending on how large your district is, if you go pre-K to 12 or if you're just a secondary district. We've had great success, and our teachers' voices are very, very much needed to be at the table when they start creating these goals.
Thank you.
Megan, congratulations, first of all, for getting 100% computer science in all of your classes. The question I had was, does it run like the TEALS program? Like, are there volunteers, or is it just you're scripting with us and we're finding other teachers, or like, how does that work?
Yeah, it's a little different than TEALS. TEALS brings professionals into your classrooms to help you and assist you in different ways and different levels of assistance. This is literally, will help facilitate, but it's within your system in your school. So it's yourself, it's other teachers that might also have computing classes if that's something that's offered at your school. It's the other individuals such as your principal, maybe an assistant principal, professional school counselor, guidance counselor, IT, whoever you think would be helpful in impacting and really recruiting the students to be able to understand that this is something they can do and they should try. We found in Maryland that our novice teachers who have moved into this area are some of our best recruiters, because they're like, hey, I just learned this too, and I want to teach this with you and work with you and learn with you. And they've been able to bring in very different, diverse students that have never even thought about taking these kinds of courses.
Okay, thank you so much.
Sure.
How do you recruit female participation or girls into computer science?
Yeah, great question. They like to come with their friends. So we have found that a lot of the peer influence is also helpful with our female students in particular. And having customized projects that you will see even within the ExCITE project that appeals to them of things that they want to work on and things that they see as maybe global problems working on a local level, things along those nature. But there's many different ways, and we can get into that within the script process of other ways to message to particular students that may have not thought about taking these courses before.
Do you have an example of what excites females? What kind of
Well, I wasn't a part of ExCITE 1, so I can pass that off to Tony or Marnie
Sure.
if you want to give a more specific
I
example.
mean, what are the kind of projects that you refer to?
The projects that we're using are generally very open-ended projects. We start out obviously with an EMS station setting, which is intentionally set in a social setting so that it's not a gender specific. It's not let's race some CO2 cars or something, which is very, very male dominated. And almost all of our activities have a social dimension, railroad crossing, metro access. So we've deliberately tried to sort of give them a much broader base in terms of their appeal. The language we use in the assignments stresses again the social dimension, the human need, which again is another factor that tends to attract girls' interest more than necessarily boys, but boys enjoy robotics, so you've already had them on board. The second thing I would suggest, if you haven't seen the ExCITE video that was created, that has some wonderful examples of females expressing why they enjoyed the ExCITE project. And I would actually say that if you shared the short video with your students, it probably would have more impact in terms of recruitment than telling them about the social dimension of the curriculum, which sounds pretty dry and boring. But there's some delightful young ladies who participate in that video, and their enthusiasm and commitment comes across very, very visibly, and they're very engaging. So I think that would also give the girls in your school a clue that this is something that they may be able to do.
Thank you. Appreciate it.
No, it's been part of our concern right the way from the beginning of the project, was to try and broaden the base. Also, the underrepresented, underserved populations. That again is another challenge, and that one's more intractable in some ways, because it's not just the assignments. You actually have to have another whole series of cultural aspects, which incidentally we are working on. Megan is working with a team that involves somebody who is very heavily engaged in culturally responsive pedagogy, and we're hoping to embed within our curriculum over time dimensions that will assist you to increase the pedagogical, culturally responsive and culturally sustaining parts of our curriculum. But as I say, that's down the way. For now, we're just happy to share with you the script process. I did put in the chat a link to Megan's slide deck, so you do have that there now for you to be able to download. I also put in there a link to the step-by-step document, which we will actually go through during the 5-day program. We will revisit the script process when you're in Raleigh, but for now, just I'm sharing it with you so at least you're aware of what's out there. But we will revisit the script process, as I say, during our 5-day period in Raleigh with you, and talk a little bit more about bringing the different stakeholders together and how we can help you as you start this process in your buildings. But I think, are there any other questions for Megan relating to the script process or recruitment of students in general?
I don't have a question, but I do want to say I put one of the videos to the to the overall project, and it looks like Michael put another one.
Okay, Good, good. Thank you.
Just put in the link to the 7-minute ExCITE video that Tony was talking about. And when we were talking about this a couple of days ago, what occurred to me about the script process is that in our case, it's especially useful because, okay, so essentially the purpose is to improve at the school level planning and student participation, but importantly for us in technology and engineering education, to develop a school support base for what it is we're doing, right? So the idea is to bring advocacy on the part of the school leadership, including and importantly the school principal and his or her designee for computer science and for technology education and for the lead role that tech ed will play in broadening the computer science delivery system. So it's really a collaborative support team that will collaboratively build in each school or possibly in each district. And you, as our teacher leaders, will likely play a lead role in establishing this forum.
Thank you,
And I
Mike.
can simply add that once you've piloted and you have students who have gone through and you've done projects with them, you can do things at your school level and invite in an evening or through a Zoom, just sort of those students talking about their experience and sharing with others and also spreading the word that way as well. That's been really successful locally with us. Once you get the traction going, it usually feeds on itself, and then you're able to even pull more students in to be able to do some really interesting things with them and to share what you've done. That's always helpful, and you could always make your own local video, which is also helpful, especially if you do recruitment into certain programs at the middle school level into your high school, if that's, you know, a pathway or a CTE pathway or something along those lines that you're also doing. It's very helpful.
Cool.
Anybody have any other questions?
Well, thank you, Megan, for joining us today and for sharing the script process. As I mentioned, we will be revisiting this in Raleigh, and we'll hopefully be able to get Megan along to do perhaps a Q&A after we've gone through a little bit more of the script process. I should mention that Marnie is also a script leader as well, so we'll be able to do some that'll help us get the ball rolling, and then we can touch base with Megan as we get closer to developing some strategies to help you in your buildings. But thank you, Megan. Thank you for joining us today. You're very welcome to hang around if you want to learn about the robotics, or alternatively, if you have other things, we won't mind if you if you disappear. As I mentioned, we are now at the point where we're wanting to go to the Hummingbird. Let me just share my screen, and Matt and I will be going through this. So you should, if everything's working according to plan, you should be able to see my screen with introduction to Hummingbird activity on there, and hopefully you can see that. The next stage will actually involve you in doing some hands-on stuff. So this is some pacing guide stuff for the Hummingbird activity, and these are the materials you'll need, and a single LED, 3-color LED, and you'll actually see a little later on we'll be using the Hummingbird itself as an input, but we'll wait till we get to when Matt starts helping out with us. So these are the resources you're going to need at hand today. You'll need your Hummingbird controller, you'll need your microbit, and the microbit needs to be inserted into that little block here with the LED panel facing up, that 5x5 LED panel facing up. You will need a battery pack with 2 AA batteries, and we ship batteries out to you, so I hope you all have batteries. And this little thing here, which looks like a sort of very poor screwdriver, is in fact a terminal tool that enables you to push down on these little buttons on top of the different terminals on the Hummingbird board. So, and what we need you to do now is to actually go to the curriculum. So I'm going to stop sharing this page and share another page. Let's see, which screen is this? Screen 3. Okay. I don't know how this is going to work. I've suddenly got one of these extra wide screens and I'm trying to see if it works. I've never used it for Zoom before. Are you able to see the two screens or is it illegible? Nope, everyone,
Yes,
okay.
see two
Okay.
screens.
Looks
Okay.
good.
Okay, thank you, good. I've gone into Unit 1 already, and if I scroll down, you'll actually see the introduction to computer control, whereas we get the Hummingbird going. And thank you to all of you who wrote in with suggestions on troubleshooting earlier in the week. But this is where we locate the Hummingbird, we connect it up, and once it's connected and the battery pack is connected, you should see your Hummingbird flashing a 6-digit code. Don't bother trying to remember it. It's not that important at this point. It will become more important for your students, however, and I'll explain why once we actually get a little bit further down the path. But when you see the 6-digit code being displayed, that tells you the Hummingbird is ready to be used. If it doesn't display a 6-digit code, try connecting it with the USB cable directly to your computer, or try replacing the batteries. But it should be flashing when it's actually plugged in to your computer. So I've got my one here. Let me just, I like to keep a Hummingbird nearby just in case. So, and let me just plug in the battery pack on mine. Okay.
Tony, may I interrupt?
Yes,
This
please.
is Trey. I could never get the Hummingbird to turn on with only 2 batteries in the battery pack.
Oh, it's a 4-battery pack. Ah, interesting. Mine's an early one. It's a 2-battery pack. Ah, okay. Okay. So if you used 4 batteries in there, it was fine.
Yes, sir.
Okay, sorry, that's my fault. I'd forgotten that the Hummingbirds now have a 4-battery. Yes, so ignore anything that says 2 batteries. Does it actually say that on this page? And in fact, that looks like that. Oh no, that is the 4-battery pack there. So did I? No, I think I did. I didn't actually mention 2 batteries in the instructions, so hopefully that won't confuse the students. So we're now back at page 1. In here there is a link to the BirdBrain Technologies connector site, and what that will do, as you probably know, is it will launch Snap. But it will launch a slightly different version of Snap. And you should see on the screen this little project that's been preloaded, and you're almost ready to go. However, this is where we came across a bug. To make this connect correctly, you have to turn on JavaScript extensions first. And that means going up to the little gear wheel up here. You're probably already all logged in. If I was doing this with students, I would make sure that they were logged in before we got to turning on JavaScript extensions. But click on the little gear wheel, go down and check the JavaScript extensions box, and you're good to go. So from that point onwards, it should be possible. You can see my my Hummingbird here is sort of flashing away. So I'm going to press my spacebar, and you can see it's now come up with a code up here. That code is what's being displayed on my Hummingbirds. You can see BB, there you can see 3, 6, etc., etc. So you do know which Hummingbird you're using. When you're doing this with your class, I just want to give you a heads up. All of the students in your class are all going to be trying to pair at the same time. There will be a long list. Usually it will put the strongest signal at the top. So, but have your students check the code against the display and the item they select. If they click pair, you will hear a little chirp from your Hummingbird, and the display will now just go blank. It'll just be clear. But what will have happened is you will now have additional palettes of information available to the students, different blocks available to the students. So if we go to control, oops, no, sorry, go to sensing, sorry. If you go to sensing and go down to the bottom.
Tony, with the new connector, those palettes are all up top underneath the originals.
Oh, yep. Yes. Sorry, Matt. Yes. Here are the palettes. Thank you, Matt, for reminding me. Hummingbird and Microbit are here. They used to be embedded within the existing palettes, and I haven't taught using this new unit. Thank you, Matt. So here are the Hummingbird different activity or different things. So let's just move this out a little so you can see all of those. There we go. So those are our Hummingbird blocks that we can use to do all sorts of neat things. And here are the Microbit things that we can use also. And if you wanted to, we can actually get rid of this now and actually open up a new project, because this, once this disappears, you actually still have everything is still here. Oh, no, it's not. Hey, Matt, did you see that it disappears if you...
Yeah, I think you have to stay in that original project.
Interesting. So is there an undo? I don't believe there is. So we've got to reconnect. Okay, so I don't know if you saw what I had to do. I went across to Robot Connections and clicked on A, and I'm going to repair. Okay. Now that has come up and it's repaired, Matt, but not with the palettes.
You need to go back to that original link and open that starter and stay there.
Got it. Okay, so we go back to here, JavaScript extensions turned on, spacebar, pair. Okay, it's paired now, and we have our blocks. Interesting. I'm gonna have to find out from Hummingbird how we get round that, whether it's just a case of, what happens if we just...
Yeah, you can do that.
Got it. Okay, so we've got rid of the code that was on our screen. And if we go back to the Hummingbird, you can see those are the blocks. So let me just move that out so that you've got this here. And if you go to the Microbit, you would be able to play with this if you want. If you wanted to just test whether your Snap is connecting and you move your display, when you click on here or press the green arrow, you will get a display, you get a line of LEDs showing on your Microbit. So, and if you repeat that and press the green arrow again, should turn them off. Oh, there you go. That turns them off. Okay, so we've turned them on and turned them off. So you've actually seen now that you've got the Hummingbird connected. Has everyone got their Hummingbird connected? Yes, everyone's in good shape. Everyone has their Hummingbird working. Good. There's thumbs up.
Yes.
No,
Yes.
mine was, but it flipped to a Zoom and I came back and now it's not connected.
Yeah, I'm having difficulty too. Like I've connected about 6 times and I keep getting unconnected. And so I'm a little confused right now.
That's weird.
And is this what it's supposed to be doing? It's just flashing.
Yes, that is that the 6-digit code?
Yeah, that's
Looks
the
like it.
code, and I think it's like
That microbit is in upside down. You're gonna need to
Yep.
turn that off. And
it's upside down.
yes, it's upside down.
Yes.
Thank you.
Yeah. That's why it's giving you a strange signal. And incidentally, the reason you actually had the code working was that you had the USB cable connected directly to the microbit, which really the ideal way of doing this is for the battery pack to be connected to the Hummingbird. So the battery pack it has a plug on the end, a 5mm plug that plugs into the power port right by your right thumb. There should be a power port on there.
Okay, I see it right here.
Yep, and the battery pack has to plug into there. If the battery pack isn't plugged in, the servos won't work on the board. So so if you wanted to disconnect the USB cable and connect the power pack, you'll actually see it will flash those 5-digit codes. But even with the USB, it should still pair.
Okay, thank you so much.
But
And
with
Tracy,
with the USB, Tony, you're saying if you're connecting through the USB, you won't be able to activate the servos?
correct. Yes. Yeah, there isn't enough power. So that's why you have to use the power pack.
Tony,
Yes.
will we have to repair the Hummingbird every time we turn the laptop back on and use the microbit again? So like every day the kids come into class, they'll have to repair every single day.
Yep. Yes, they will. And they get used to it very, very quickly. They just know it's part of the setup process.
And Tony deleted that initial startup code, the space bar. There's a block there in the palette that will connect again if you do delete that from the screen.
Okay. Oh, in the connect. Yes, I don't know if you can see this here. If I bring Connect A out, that will actually reconnect your microbit. So yeah, you may be able to use that, Tracy, to help you reconnect. So if let's try it. I'm going to disconnect A, which is disconnected.
Yeah, I did that. I'm suspecting right now my batteries are low based on some things that you said. So what I'm doing now is replacing batteries to see if I'm getting more success.
Got it.
Thank you.
Got it.
Tracy, Tracy, the quick fix for today might just be to grab the USB cable. And,
Thank you.
And provide some power that way. I don't think we're going to use the servos today.
Thanks a lot.
No, we're not. So that would work.
What's interesting, I have the Hummingbird blocks showing up, but I don't have those new portions of the palette where it says Finch and Hummingbird and Microbit. That doesn't show up.
Did you use Tony's link from the curriculum, or did you have a favorite that you pulled up, Mike?
I think I just used the snap.birdbrain technologies link.
No, that's that link is an old link and it won't work. It will it won't do what we need to do.
Can you put the link in the chat, please?
It's in the curriculum, Mike. It's page Which one is it? Let's have a look. It's also in the slide deck too.
It's in the slide deck.
Yep.
Where is it in the slide deck? I'm sorry.
It's in the introduction to Hummingbird. Oops.
What slide number?
Oh, no, you actually have to go to the curriculum. It's slide 20, you click on the curriculum and it'll take you to page 1, start. And as you go down there, scroll down about halfway or 1/3 of the way down, and there's the Bird Brain Technologies Hummingbird Connector site. That'll take you there. I've copied the link address, which I will put in the chat as well, just in case anybody else needs it.
I'm good now, by the way. The batteries were the problem. And that's why I had that problem with connecting when I emailed you before, and I just didn't realize that my batteries were just too low. Thank you guys for your patience.
Okay, good. Incidentally, the first time you start using these resources with your students, these will be the hiccups that you'll encounter. So it's good to sort of see some of the troubleshooting steps. And as I say, Matt's been teaching with Hummingbird now for several years, so he's got a lot of experience under his belt. So, and I'm sure he'll step in when we stumble. Okay,
so I have a couple of quick questions to review. And
fire away.
So so every day the kids come in, they're going to have to repair. Are they going to have to go to that same page to follow that same link, or just have them bookmark the link to make it easier?
Yeah, bookmark the link. Yes, and by all means.
And then I believe Mr. Davis was saying that when we get there, we could even just make a block, take that code that says when space key press connect A, just turn that into a block, its own block.
It's already there. If you go to the microbit palette and it's towards the bottom, 3 from the bottom, you've got a connect or a disconnect.
Yes.
All right. Yeah, I see it. So you go to the microbit instead of the Hummingbird.
Correct.
Yes.
Correct.
Or you could leave that code that Tony deleted, the when spacebar is pressed and then the connect, leave that in the code and just don't have the students use the spacebar for any other control in your program. And they're going to save their program at the end of the class period. They come back the next day, they open the program and that code is there and they just click that again and they pair.
And we have to make sure we follow this link so they get the palettes for Finch, Hummingbird, and Microbit.
Correct.
Correct.
Yes, they're the only they're the only ones that will work. There was a different process before, which is what Mike was using, and that won't save the projects. Students can't retrieve any Hummingbird project using that old link. Which is why Bird Brain Technologies have evolved a new link for us, which makes it so much easier to use. It was a real pain in the rear end before.
So the links we've been following with Marnie just to work within Snap, we're not going to be using those unless we're just programming in Snap.
Correct. Absolutely correct. Yes. And incidentally, once you have saved a project in a Hummingbird project, it will load the blocks that you have embedded in your code. So if I saved something with the display, for example, let's do Where's Forever. So.
Tony, I'm using that Bluebird connector, and that works perfectly fine with me. It opens a clean Snap without the robot connection thing, but it does have all the blocks. Will that work as well?
No, it won't, because when you try and save it, you'll save it there, but the students won't. It won't save in Berkeley. So if the students use the Bluebird connector, what will happen then is, and I'm assuming you can. Oh no, you can't see my screen. I'm not sharing. Excuse me a second. Let me share again.
And while Tony's doing that, I think the Bluebird connector gives you a slightly different look to Snap than the one that we've written the curriculum to match. So
yeah,
it might be best to try to follow that link from the curriculum to get started.
Okay, no problem.
Yes, yeah. I'd highly recommend sticking to that there. But this program here, when I click that, that should all it's doing is keeping that there. And if I wanted to, what I could do is sort of let's stop that using the red flag, and I could duplicate this and put my forever. Oh, I don't need two forevers. I just need one forever. So if I now find a weight block and put it in here, and get rid of that, get rid of that, get rid of that. So basically, all this is going to do just a very simple program that will turn the light on and off, and you can see it pulsing. So not a very complicated program. But when I got and save that, so, oh, it saved it as Starter Project BLE. So make sure you rename it. Otherwise, you're going to lose whatever you had. So this needs to be my light display 723. Save that there. Okay. So I've now got a program up there. If I came out of Hummingbird altogether, completely restarted Snap, I would be able to bring that up and I would see the blocks, but it wouldn't automatically connect with the microbit. You'd have to repair. But it does mean the students' work stays in Berkeley and they can bring it up. And once they repair, that will work perfectly. That was where it wasn't working with the old system. And that's why it's important to, follow along with what we're doing now. Okay. So I'm going to stop sharing this screen if I find it. Problem with multiple screens, you lose where you are. Okay, I'm going to share screen 2. I've now moved, this is in the curriculum. I've now moved over to, excuse me, page 2 and light things up. What you'll find is in our curriculum, you'll actually find there's some informational parts in here that allow you to give the students some information about control systems. And if you wanted to, there's a small activity here where you can ask them to list things that are going on in the real world. The intention of this is to make students aware that microcontrollers, which is what a microbit is, 99% of the computers used in the real world are actually microcontrollers. They're not keyboard screen. The keyboard screen is 1%. My car has, I think it's 159 computers in that car. And so you can see what happens. Your washing machine will have generally 3 or 4 computers in there or microcontrollers in there. So it's really a chance to give the students an awareness of microcontrollers and how they work. They have inputs, processors, outputs. What we've missed out on here is feedback, but we'll worry about that later. But you're actually basically getting them to think about microcontrollers and how they're used in society. But what we're going to do today is we're actually going to start here. Let's see, let's reduce that size. Oh, it's going larger. Why is it going larger? I wanted to go smaller. Okay. That's really interesting. Okay, what we need you to do is to find one of the single LEDs. Doesn't matter what color it is. Incidentally, a hint. The color of the wire will probably tell you the color of the LED. So if you'd like to find your a two-wire LED, and there's that little tool that will help you insert the wires. And what we're going to do is we're going to insert the wires into the little, the first yellow block that's labeled LED 1. And so we'll give you a minute to locate all of your the bits and pieces, and we'll ask you for thumbs up once you've actually got it connected. Incidentally, if you look carefully, you'll actually see that the LED 1 yellow block has two terminals. One is marked with a plus and one is marked with a minus. The minus terminal must be connected to the black wire, otherwise it won't work. The green wire, or whatever color wire you happen to have, has to be connected to the plus. And polarity is really important with everything to do with computer control. And so your students will very quickly become adept at troubleshooting. If the wires aren't fully inserted, if they're just partially inserted, sometimes it doesn't work. If the wire is so fully inserted that there's insulation in there as well, that can often cause confusion too. But as long as the wire is in and it seems reasonably firm, you should be in good shape. So hopefully everyone is getting their wires now connected. So looking around to look at faces to see if people are connected. Oh, yep, there we go. Walter's connected. Tracy? Not yet. Okay.
Would these be the wires that I'm so confused with this part.
Yes, a single LED looks like this here on the screen. And it will probably be all the LEDs are usually clipped together with a little wire tie. So you may end up having to actually separate them.
Okay.
There we go. So let me stop sharing for a second. So what I've got here is a single LED. You can probably see what shape it is. All the participants list is right on the screen, so I'm just going to get rid of that. Yes, so that's a single LED. It's sort of like a clear, small button-like device. And this, because it's red, you'll actually see this is red and black. So this is our single LED. And what we're going to do is we're going to put that into the Hummingbird board. But let me get back to where that is. And let me share again so that you can see exactly where it goes. Okay, so you should now see the wires being inserted into the yellow terminal, LED 1. And as I mentioned, the black terminal, the black wire must go into the terminal marked with a minus, and the colored wire must go into the terminal marked with a plus.
And you're going to grab that orange tool to help you push down on the
Yes.
tab in front of the hole for the wire so that it actually inserts. And then when you release the tab, it should grab the wire.
So just wait.
The orange tool. Where did it start its life in this box?
It was at the at the bottom on the left hand side for me.
You could use a fingernail or something small to push on it.
Yeah, a ballpoint pen works really well too.
Okay.
Yeah, anything that pushes down the terminals is really what you're looking for. Preferably not metallic, but anything anything that's easy to sort of get to and push that terminal down.
I mean, if you have reasonably small hands, you can just use your finger.
The kids are usually very adept at doing this very quickly. So cool. So has everyone managed to get their LED connected? Tracy, yes. Luanda?
Well, I think I have it connected, but nothing's happening on the microphone.
No, nothing will. Nothing will.
Oh,
Don't
okay.
worry. Oh,
Okay.
that's all we're doing is connecting. Okay, good. What we're going to do now is we're now going to move on, and you actually now need to be in the Snap screen. So, and you'll see I've clicked on the Hummingbird. So I'm going to now change from sharing this screen, to sharing my other screen. So I'm going to stop that share, and I'm going to share the programming screen. Okay, screen 3. Okay, so now I'm down in my programming screen. If I look over here, you'll see that there's a block that's labeled Hummingbird LED. And you can see we've got Hummingbird A, which is the one that we have connected. You can see down here, we're working with Hummingbird A. And you'll see here where we've got LED 1 is in here. That's the LED that we've inserted the LED in, but it's at 0%. Let's change that to 100%. So I've now inserted 100% in there. And then click on the block. See what happens. Hopefully it turns your LED on. Give me a thumbs up if it did. Oh, it didn't? Okay,
I cannot find my Hummingbirds blocks anymore.
Then you're going to have to go back to that little the link code on page 1. That actually will reopen, that'll repair your Hummingbird.
Okay, I'll give it a try.
I'm just connecting up my my LED.
Tony, are you able to share your screen?
I figured, oh, I'm sorry, go ahead.
So one LED flashing, one LED rather turned on. So you said you've got your, Tracy, you have yours.
Are you able to share your screen, Tony?
I thought I was. It should be showing the programming screen. Let me share again just to make sure I've got.
Okay. I saw emails, unless it's my screen.
So are people seeing my programming screen?
The one so on the right is the programming screen. He's got both.
Yep, correct.
Yeah.
Yep,
Okay.
good.
There are a
Thank
bunch
you.
of screens up, Tony. You've got your email visible.
Oh, okay. Rather than, okay, let's get rid of that. Yeah, I did have the curriculum over there on the last time. So what I can do, let's escape up here. Okay, what we've got what we've got here is our Hummingbird out here, our block out there, and if we turn that to 0 and press it again, you should now that should have turned. Sorry, and click on it. It will turn off your Hummingbird, your LED. So do you think you guys could now write a small program that makes the LED flash on and off in a 1 second period? So let's go for it. So you're probably going to have to use the control palette to help you get started, and you'll probably need to duplicate your Hummingbird. So see if you can create a program to flash your LEDs on and off. Okay. Let me know when you've got that done. Tracy's got hers done. So thankfully, it's a pretty straightforward program. You can now see on the curriculum screen that basically we've got a control hat and a forever and a couple of weights. And so, well, let's make it the 100% first.
I got something going here.
There we go. So in theory, if I've got this working correctly, oh, there's the LED, which is much more important than the Hummingbird. There's the LED. So if I click on this, you can now see how it's flashing on and off each second. So now you have successfully managed to write a program that links to the Hummingbird using Bluetooth. We're connected wirelessly from my computer straight to the microbit itself, which means it's so easy for us to be able to build the Hummingbird into projects, because we don't have to worry about a wire going all the way back to the laptop or the computer. Okay, so moving on from there, you should really now save your work. So we're going to do save as, and light display, I'm going to save again. It can still be used. I'll use the same name. So I've saved it as that, and now I think, yes, there's some more information about binary and analog. Sorry, about binary code, but we'll worry about that when we actually get together with you. On this page here, we're going to use the tricolor LED, and the tricolor LED is a slightly different animal. It's in your box, and you will distinguish it by the fact it has 3 wires. It looks like an LED, but there are 3
That's
wires
what
coming
4
out.
wires, funny.
Oh, 4 wires. Sorry, Mike. Thank you. Thank you. Yeah, there are 4 wires coming out. It actually says that on the curriculum. And what you're going to do with your color light is you're going to connect it to the green blocks, not the yellow blocks, the green blocks that say RGB minus. It'll actually say tricolor on the Hummingbird board. So if you look there to the left-hand side, oh, well, I'm looking at the front of my board. The green blocks are to the left of the Hummingbird, the LED blocks. And what we're going to do is we're going to connect the tricolor LED, and the connections are at exactly as suggested. The red wire goes to the R, the green wire goes to the G, and the blue wire goes to the B. So please connect them in that order, and then the black wire goes to minus.
Are we disconnecting the single color LED?
Yes, please. Sorry, I should have made that clear. Yes. Yeah. It actually doesn't make a great deal of difference, but it would certainly, you would want the students to keep all of the parts tidy. So having them doing so would help. Yeah, there doesn't seem to be any way, if you close that BLE, you lose the palettes. So you have to use save as and keep the BLE active, which is something of a pain in the rear end. Yep, you do. So we're going to have to work with Hummingbird, with BirdBrain, Matt, because this is going to be a little bit confusing for everyone, because what's happening is if you try and create a new project, it seems to delete the blocks. And so let me try something.
Well, Tony, I just pulled up the railroad crossing, and I don't know if all of them are written this way, but I wrote the railroad crossing to say click here to connect to the project. So I wrote it with the starter project for each of the new projects. So that's at least a little less of a hassle, I think.
Yeah, what I just tried something, folks, and it does look like if I open up, where's my lights? My light display 733. Yes, so if you have saved a project in your in the cloud and you reopen that project, it will bring the blocks back. So that's a way of reinstating the blocks. And obviously now I want to do some new code. So I'm going to get rid of that code and I'm going to actually save as before I do anything here. And I'm going to have this as light display tri color. So it has a new name. It's been saved and we're now ready to go. So are people ready to start doing some programming with the tricolor? Let's hope so. Good. So if we go to the Hummingbird palette once more, and let me move that out. Now, are you seeing my programming screen, folks? Okay, good. Okay, thank you. You'll notice here that there's a Hummingbird tricolor command, block rather. And if you, for example, put 100% in the R box and leave everything else as it is, what should happen when you click on this is you should have just the red tricolor LED illuminated. And if you wanted to experiment, you could put that to 0 and turn it off. And you could try the green and see if the green works. And similarly, you could experiment to see if all 3 colors of your tricolor light illuminate. Now, you wrote a program already which gave us a flashing light. It won't be very difficult for you to obviously be able to recreate that here with the wait command. But this time what we're going to do is we're actually going to duplicate that 3 times. So we've now got all of this in here. And then if we do 100 here, 0 there, 100 here, 0 in all the other boxes, and 0, 0, and 100. So we have 100 in the R, 100 in the, 100 in the red, 100 in the green, and 100 in the blue, with a 1 second delay between all of those. And when you click that, what you should see is each light coming on in sequence. So that's given you the chance to program the tricolor LED so that you're actually seeing exactly what the tricolor LED is supposed to do. So we're going to save that. We already have it named as light display tricolor, so I'm going to save that. Now I've got another part of the curriculum. If you look at the curriculum side of the screen, of my screen, you'll see that on the back of the microbit, if you look on the back of the microbit, on the front of the microbit, there are 2 buttons, A and B. They're labeled in red, so it's not easy to see the labels, but they are on there. The A is on the left and the B is on the right. But if you look on there, you'll see the 2 buttons, A and B. They don't do anything at the moment because obviously we haven't done anything to actually read those buttons. But there is an there is a button on there. And what we want to do is to see if we can use that button to start this process and to maybe stop that process of flashing the lights. So how do you think you might be able to do that? Do you think you've got any idea how that might work?
Go to the microbit palette and there's microbit A, button A.
That's it. You've got it. So we need to go into the microbit palette and bring out button A. So now button A all by itself isn't going to do very much because we've got to know whether it's been pressed or not. What do you think happens then? So we know we need to use an if. So rather than a 4, so we've got an if button. Will that work, do you think? You think that code would work? What do you think? Okay. Is it working for you? Anyone using that code? No, it shouldn't. Why isn't it working? What do you think has gone wrong? We don't actually know if that button is true or false. So we probably need to do something that helps us work out if the button has actually been pressed.
I got something working here. Whenever I press it, it shows a pattern on my. That's easy to see. Unblur.
Oh, I see. Oh, wow.
But I did need a forever loop and an if statement. So if the button is pressed, show that little pattern.
Got
there.
it.
Yeah.
So in control, so we probably needed an if then else as well. So, whoops. Oh, so, hey, Matt, I think I've got lost here.
So that code is really tiny on my screen.
Oh, okay. Let me see if I can.
Can you increase your blocks?
Yes,
The setting button should allow you to change block size.
Oops, made too much. That was a little bit on the so. Okay.
That's better. Yeah.
Okay, so and we can move our stage over here as well. Let's get that over there so it's way out of the way. And this we can disconnect here for there and move that down there. So
put your microbit A back in the if that's above.
Got it.
And then just drop that first Hummingbird. And probably need all that in a forever. No, the
Everything goes in
forever
front.
needs to be outside the if. Yeah. And then green flag, and then A button should turn the light on.
And then you can put something in to stop it until you press it again.
Correct.
Yes.
Correct. And in fact, what you might want to do then is if button B is pressed, then you could actually perhaps turn the light off with button B. Has anyone got it? So it's turning off as well? Oh, well done. Well done. Well done, Tracy. Okay. We've actually now gone through pretty much through the stuff that's in our lab in the this particular page. But what we're going to do now is hand over to Matt, because we're actually going to show you how the microbit has all sorts of other features that enable you to do some really interesting things. And Matt developed a variation on an existing project that's within the BJC curriculum, which is the Pong game. And those of you who are around about my age, so those who were born before 1980 may remember Pong. It was an electronic game, a console game that was invented, I think, by Atari back in the 70s. And paddles move up and down, and a ball moves between them. Your students will not have a clue, and when they see it in on the screen, they're going to say, "People actually paid to play this." But you know, it gives you a chance to remind them that things started far less sophisticatedly than Minecraft and other things like that these days. Matt, if I stop sharing, would you like to take over?
I could do that. I'm going to ask you to jump off of Tony's slides for just a moment. We got a little bit of a hiccup here, but I'm going to throw a link into the chat for you.
Oh, that's the starter code.
And that will actually take you to the updated version of the Pong game. And Tony's link in the that he's got you going to is going to be the old version. So we want to make sure that we maintain what we've got. So let me share screens here. The link
So
should...
do you want us to click on that link before you share screens, Matt?
Either way, but that link is what you need to get started, and that'll take you to the page that I just shared.
Got it. Oh, got it. Okay, so this takes us to the curriculum. Got it.
Yes. So there's the page, the updated page. And so it kind of introduces, and this is actually going into the optional projects, which I don't know that we've talked a whole lot about yet, but at the end of each unit, there are some projects that students can do. I like to use them as a formative, or not a formative, but a summative assessment of how they've done. The optional projects don't give them quite as much assistance in the coding. So this one is, I think, the only, well, this one is the only one in Unit 1 that is going to use Hummingbird, but the other optional projects challenge the students a little bit to use what they know. So if we get down to step 1, click here to load the starter code. And again, it's the new Hummingbird connector. So we would connect to the robot, and of course my tabs are right underneath of where I need to be to see what I'm doing. If you bear with me there. And that tab didn't work either. So what have I done? That's there. That's there. Okay. Trying to get back to the curriculum for you. So the steps there ask you to click on the green flag to see how it works on its own. And then you can play the game a little bit by using the up and down arrow keys on the keyboard. And then once you alter the code, to use that microbit A button block again to make the code move the paddle up and down the screen. Do the same for the B, and see if you can make that work. So I'll give you a minute or two to play with that, and don't get too hung up on playing the game. But if we hit the green button, and I didn't turn on my
JavaScript, yes.
JavaScripts again. So hit the green button and we can connect or we can play. And again, the kids will be somewhat amazed and they will get distracted and want to play, just like me. But that's using the up and down arrow keys. And then once you connect to your robot, can you change my code so that it actually uses the robot, the A and the B button, so we have a controller instead of using the keyboard to manipulate the game. So if you haven't already got that figured out, see what you can do with that.
Yeah, that's working for me.
Good. All right. Looks like Walter's got it going on. Anybody else have success, or are we still having issues?
I've got that ball bouncing around my screen. Was there another, what was our goal here?
You can play the game with the arrow keys. The up and down arrow would move the paddle. And then we could also connect to the Hummingbird and use the microbit A button A to move the controller up the screen, or the paddle up the screen. And then we could switch that up and add another button B that would allow it to move down the screen instead of the up and down arrow.
Okay.
And then we can play with the Hummingbird as our controller as opposed to using the keyboard to play the